Hello again, fifth graders. Ms. Jagodnik here. This is our last lesson in topic 13, which, as you know now, is all about order of operations and using expressions to represent and solve problems. So as the last lesson in the topic, this deals with more complicated word problems and how to reason your way through them, to write an expression that could be used to solve them, and also to actually solve the expression and make sure you can get the correct answer. We'll have to use PEMDAS in order to determine how to set up the expression, whether we need parentheses, and making sure that you solve it in the correct order, it gets you the right answer. So all of it ties together. I'm going to do with you the two problems on page 761. They're numbers 1 through 6 in your book because each problem asks you several different things about it. But we're just going to talk through the problem together, come up with an expression that can be used to solve it, explain how that expression works, and then, of course, solve it to get the actual answer. And in your book, you can break it down into the various parts and write them in the right place. Or if you already tried it, you can check to make sure that your answers make sense with what we're doing. So let's get to work. Numbers 1 through 3 have to deal with this word problem right here. So let's read it carefully first and think about the different parts of the problem and what's really going on in this situation. Todd has 4 baseball card albums, like the one pictured. And you can see there's a diagram of the album here. And there's also some information below, which we know by now we should never ignore. That might be something we need to solve the problem too. He lets his best friend Franco choose 5 cards from each album. How many cards does Todd have now? Okay, so let me break this down little by little and reason my way through it first. Todd has, here's one piece of information, 4 baseball card albums, like the one pictured. And I can see in the picture that it tells me it's 42 cards in each one. He lets his best friend Franco choose 5 cards from each album. And I want to know, how many cards does Todd have now? So the first thing I need to think about is, how do I represent each part of the problem? What numbers am I going to use, and what operations make sense? So starting with the beginning, which is what number 1 asked you to write an expression for. How many cards does Todd have at the beginning? Because I know at this point the situation is he has a bunch of cards and albums. His friend is taking some of them. I want to know how many he has now. Notice they didn't use the word left because they're trying to be a little tricky and not give you a big clue that it's subtraction, but it's got to be subtraction. He's got something. He's losing some of it. I want to know how many he has now. It's got to be a smaller number. I'm subtracting. Okay. So I'm just going to write left under now because that's really what it's asking, and that makes me think subtraction. Okay? But that doesn't mean I'm subtracting right away. It means I'm going to subtract at some point. The first part of the problem is to figure out how many cards he has at the beginning. What do I know about that? I know that he has 4 albums, and each album has the same amount. So that sounds to me a lot like multiplication. An album is a group. There are equal groups. I want to put it all together to find out his total. So it seems like the first part of the problem, which is question 1 in your book, would be 4 times 42. He has 4 albums with 42 cards in each one. That's definitely multiplication. Now I want to figure out, how many does his friend have? Because that makes sense. If I know how many he has, I take away how many his friend took from him, then I'll know what's left. So his friend is taking 5 cards from each album. So he's not taking 5 albums. He's taking 5 cards from each one. So that means, looking back, Todd has 4 albums. He's taking 5 cards from the first one, 5 cards from the second one, 5 cards from the third one, and 5 cards from the fourth one. So altogether, he is taking 4 groups of 5 cards each. So I have here that Todd has 4 albums, 42 cards each. Franco is taking 5 cards from each of those 4 albums. And I want to know how many Todd has left. Well, I'm going to take that away. Here's what Todd has at the beginning. Here's what Franco takes away. That means My answer is going to tell me how many Todd has left, how many he has now, which is what I want to know. So that's the answer to 1 and 2. Here's the answer to 1. This is what Todd had at the beginning. And here's the answer to number 2. This is how many he's going to have after Franco takes the cards. Now, number 3 asked me to solve it. Figure out how many cards does Todd have. So let me do that. Notice I did use parentheses here. I actually did not have to, because according to order of operations, if I had no parentheses and I had just written the equation 4 times 42 minus 4 times 5, with order of operations, I would have gone through and I would have done the multiplication and then gone back and done the subtraction. So the order would not have changed. But I like to put the parentheses in again to make it really clear. This is the first thing I'm doing. This is the second thing I'm doing. And that's the third thing I'm doing, just for a little clarity. Okay, but now I'm going to do each step in order. 42 times 4. I have 4 times 2 is 8. And 4 times 4 is 16, so 168. Todd started with 168 cards. Okay. Obviously, 5 times 4 is a fact. I don't need to calculate anything there. He's giving Franco 20 of them. Okay. Now I just need to do my subtraction to find out how many he has left. Okay, 168 minus 20 is 148. So Todd has left 148 cards. There's my answer. When I solve the expression, that's my answer for number 3. Okay, let's go on to the second problem on this page and see how we can talk and reason our way through that one. Brandon is filling a flower order for a banquet. He needs 3 large arrangements. I'm just going to grab all of my important information here. And, gee, that usually means addition, but we'll wait and see that makes sense with the problem. 12 small arrangements. So seems like we're talking about 2 different sizes here. The large arrangements each contain 28 roses. There's my each again. That sounds like we're talking maybe multiplication. The small arrangements each contain 16 roses. How many roses does Brandon need in all? Okay, in all tells me I'm looking for a total. I'm either adding or multiplying to get my total. I should end up with a much larger answer than I started with. Okay, so I have 3 large arrangements. I have 12 small arrangements. I know how many flowers are in each large arrangement, 28, and I know how many flowers are in each small arrangement, 16. And I want to know the big total, okay? So it seems to me like I have 2 different things I'm talking about here. I have large and I have small. And I know the number of flowers in each of those different types. So what seems to make sense to me is to put the types together. I can figure out how many flowers he needs in the large arrangements by putting those 2 pieces of information together. So here's 3 large arrangements, and each of them are 28 roses. So that's 3 groups of 28 roses. That tells me how many roses I have in the large arrangements. Then I can put together my information about the small arrangements. I have 12 small arrangements, and each of them has 16 roses in them. So that's 12 groups of 16. That tells me how many flowers I have in the small arrangements. Now, the question doesn't ask me how many large, how many small. It asks me how many roses does he need in all. So here's the roses in the large. Here's the roses in the small. If I want to know in all, I just have to put them together by adding. And that will equal the roses that he needs in all. So number 4 asks you to write an expression to express the total number of roses. So if I take this off, there's my expression. Once I put that on, it's an equation, but here's my expression. That's all I need. And again, I don't need the parentheses. If I did not put them, order of operations, I would do the multiplication first anyway, but I like to put them to make it nice and clear which things I'm putting together and what order I'm doing things in. So there's my expression, my answer for number 4. Question number 5 asked you to explain how all the numbers, symbols, and operations represent the problem, which we just did. I'm multiplying because we're talking about groups and an equal number in each. I'm adding because we want a total in all once we put those two totals together. And the numbers came right out of the problem, putting together the numbers about the large arrangements and the numbers about the small arrangements. Okay, number 6, the final question on this page, asks you to actually solve the problem. So if I look at what I have to do, my first 2 steps are multiplication. So first I'm going to do 28 times 3 using my multiplication algorithm here. 3 times 8 is 24. Put down the 4 and I'm going to regroup that 2. 3 times 2 is 6 plus 2 is 8. So I have 84 roses in the large arrangement. Okay, now I have to do 12 times 16. I like to put the bigger number on top. That's just how I am. We know commutative property. Doesn't matter what order I do them in. 2 times 6 is 12. Regroup that 1. 2 times 1 is 2, plus 1 is 3. Now I'm done with this one, and I'm on to the tens, so I know I need to annex that 0 there because I'm multiplying by 10. 1 times 6 is 6. 1 times 1 is 1. This is left over from last time. I'm not using that again. And now I add, and I end up with 2, 9, 1, 192. So 192 roses in these small arrangements. Now I just need to add those 2 numbers together to get the total. So finding some space to squish this in here, I have 192 plus 84. 2 plus 4 is 6. 9 plus 8 is 17. Carry the 1. 1 plus 1 is 2. I have a total of 276 roses that Brandon needs. So that would be my final answer to number 6 on this page. So that's an example of how you can break down a problem, annotate it, reason your way through what operations make sense, how do I put the numbers together, and then solve it with the different operations and make sure that your answer makes sense. So you can go on and try the next page, page 672 on your own, if you haven't already done that, and then your practice buddy for homework. And then tomorrow, Miss Singh will guide you through the beginning of a totally new topic. Have a nice day.